Hi.
Hi. Are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi. Are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hey, hi, very good evening, everyone. Welcome to another session of this live mock DSA interview where we conduct live DSA sessions where we interview our candidates. Very happy to see you all here. And I just get a quick confirmation if my voice is clearly audible and if my screen is visible? All right, thanks everyone for the confirmation. So let me introduce myself. My name is Suniti, and I'm a mentor here at Geeks4Geeks. And today we are going to interview our candidate whose name is Divyesh. So let us welcome our interviewee. All right, hi Divyesh.
Hello everyone. Hello ma'am.
Hello. So how are you doing?
Fine.
All right. So let us just start with the introduction of yours.
Hello everyone. My name is Divyesh Jivani and I am currently in my final year of BTech and I am studying at Indus University Ahmedabad.
Okay. Divyesh, I think you were not clearly audible. So can you please give your introduction once again?
Okay ma'am. Hello everyone. My name is Divyesh Jivani. I am currently in my final year of BTech and I am pursuing it from Indus University Ahmedabad.
All right. Thanks for introduction. So let me explain you the procedure, how we are going to proceed. So a Google Doc link has been shared with you, right?
Yes.
So I'll be writing down the question there. And first of all, you need to explain your pseudo, like you need to explain your approach. Then you can explain the pseudo code. And then I will share the link of the GFG practice portal. And then you can code it there. Okay.
Okay.
Yeah. So can you please share your screen?
If the screen is visible. Hello. Hello.
Yeah.
If the screen is visible.
Okay, yeah, yes, your screen is visible. Can you open the link? Yeah, okay. So let me write down the first question. That is, given a binary tree, you need to print its level order traversal in spiral form. Okay, just give you the first test case. Control C. And okay, so if this is the binary tree, All right. So in this case, the output that we are going to print is this. Okay. So as you can see, the root is printed as it is. Then first we are moving from left to right. That's why we have printed 20, 30. And then we are moving from right to left. Okay. That's why we are printing 60, 40. So this is how you need to proceed for the entire tree. And you need to print the traversal in the spiral form. All right.
Okay, ma'am. So if we have the fourth level, then we have to go from left to right, right?
Yes, exactly.
And if we have the uh, null binary tree, then we have to
Then you
return null.
Yeah, exactly. You have to return answer in a vector.
Oh, okay, okay. So I have to return empty vector, right?
Yes.
For starting, we can start from root node here, which is 10. Then we go level wise. We can go level wise in using BFS algorithm. Then we store it in vector. Then if it is the level is odd, then we go from right to left. And if level number is even, then we go from left to right.
Okay.
I can write it down. If level number is odd, then we go from if level number is odd, then we go from uh, right to left.
Okay. One thing, you are starting your level number from 0 or 1.
1.
Okay. So 10 is at level 1, right?
Yes.
Okay.
If level number is 1, then we go from left. Like this is my approach. The time complexity of this is big of n, and the space complexity is also the queue taken the space of big of n.
Okay. So how are you traversing it? I mean, by what process?
By doing BFS, first I will put root node in queue.
Okay.
Then I will move further. If the children, all nodes I cover, which are in the queue, and then I will traverse again the all nodes. Like uh, I go from level wise. Yeah,
Okay.
I explain. If like if I am currently standing at level 2, right? Then we have 20 and 30 in our queue, right?
Okay.
Then we will uh, we put out 20 and put its children in queue, like 40. And then in second iteration, we put out 30 and we put 30, I think 60 in the queue.
Okay. Tell me one thing. When you will be traversing from right to left, so in that case, the right nodes will get inserted first inside the queue, right?
From right to left,
Like suppose when you are traversing 30, 20. Okay.
yes, 30, 20.
Yeah. So when you are traversing that, so in that case, 60 will be inserted first and 40 will be inserted first. 40 will be inserted later, right?
No, no, no. I will traverse the in same way, but I will reverse the vector.
Okay, you will reverse the vector. Traversing, you will do as usual and then you will reverse, right?
Yes, if the level is odd, then I will reverse the vector. If it is even, then I don't have to reverse the vector.
Okay, so you will be creating a temporary vector for this to like store it and then reverse
Yes,
it. Like
I
you will have.
yes, yes.
Okay, so all right, this approach seems fine to me. Can you write down the pseudocode?
Okay. We got the root of binary, right?
Sorry.
I got the root of binary tree, right? For
Yes, yes, the root is
I
given to you. Yeah.
then I will start from Q. Uh, node structure. In Q, I will push the root. Then uh, I start traversing. In Q. First, I will take uh, size of the Q. The size of the queue is taken because of we are traversing level wise. We don't have to like extract 40 also, right? That's why I am taking size that queue currently has. Then we can get the size of the level, current level. In the second level, we have size of 2, right? That's why I'm taking the size.
Okay.
Four. Then I will start traversing in queue by doing size minus one because
All right.
every time we put out
Just
element,
a Div, just a second, Divyesh. Can you please consider keeping your laptop at some stable position? Because I think that is not very stable and like yeah.
now it is fine.
Okay.
Like if we thousand uh, node, the front element of queue will be extract out and will pop out that element. Now, if current node has its children, so we have to extract the left children first because we are considering the in left to right manner firstly.
Yeah.
Then if the level number is even the odd, then we will reverse it. That's all. I forgotten the point.
Okay. I
Extra
mean,
vector.
right now you are doing a normal level order traversal, right?
Yes, yes, normal level order traversal. And if the like level number is odd, then I will
Yeah. Yeah.
reverse it and store it in
Okay.
answer. I will keep also the current level.
Actually, you don't have to return a 2D array, you need to return a 1D array.
Okay, then how to do it? Now, if the current node has left children, then we have to push it into the queue.
Okay.
Now, if the current node has right children, then we also put it in the now for vector x currently have the current level in left to right manner, right? So now if we check level in the code, this is the binary condition that will return true if the current number is 4. Then we have to push the values of current vector in reverse manner. Else it exits. I think this is hello.
Yes, I'm listening.
I think this is fine. Is it okay to you?
Okay, just a second, let me have a look. Current. Okay. All right, the approach seems fine to me, but what is the space complexity of this code?
Space complexity is like q is taking big of n space, and the vector x is taking big of n space. That's why big of 2n, uh, the space complexity will be big of 2n,
And
and
space time
we can
complexity.
assert, and time complexity will be big of n.
You are reversing the vector, right? You are traversing the vector like inside every iteration.
Yeah, yeah. So time complexity will be only 2 into n also.
Okay. All right. I'll share the question link with you. Okay, before moving ahead, you have used here this statement, right? If level number and 1 to check if the level number is odd or not, right? So
Yes.
can you tell me what is special about the binary representation of odd numbers so that when we do it and with 1, we get 1 as answer?
Yes, because if any number is odd in a binary representation, it have the zeroth bit set. Like if we have example in 3, we have its binary representation 1 1, right? So
Yes.
this is zeroth bit, and in
Okay.
1 we have also the like the first bit is 0 and the zeroth bit is set. That's why we take the end of this, it will return 1. So for every odd number, we have zeroth bit set. That's why I taken this. And this is the binary operations are very fast compared to arithmetic operations.
All right. I have shared the GFG's practice portals link with you. So can you open it and code it there? Yeah.
This function will return if Q is empty or not. Right. That's very very 'll get if the left children is there or not. If right children is there. 1 HK should be there. If the root is null, then we have to return incorrect, right?
I guess you need to insert the data inside the temp as well, right?
Yes, yes, yes. I remember.
And also, if I remember, you were starting your level number from 1, right?
Oh, I,
Okay. Okay.
one check. I check.
Okay, you can submit it. You should do compile and run first, right? All right. So the code got accepted. So okay, that is correct. It means. But all right, tell me one thing. Here you are doing this, reversal thing inside the traversal, right? So
Yes,
is there any method by which you can avoid this reversal thing?
yes. We can avoid this thing if we like. Let me think.
I mean, that is an additional operation that is taking place, right? So if you can try to avoid it,
I am at even level. Then I, I think that is not possible.
okay. So I mean, this is the only way by which we can do this question.
We can do also by, but it will take space extra if we do it
So extra
from
space you
here.
are already taking, like extra space you are already taking by using this additional vector, right? This temp vector.
Yes, yes, yes.
So here what you
Yes,
are
we
doing
can.
that you are using an additional space as well as you are doing an additional operation. So maybe you can take additional space and avoid doing this additional operation.
Yes, yes, we can do it from DFS. Like we pass the answer array, and if the level number is given, then we go for right first and left afterwards. And if the level number is current level number is odd, then we will go left first and right afterwards.
DFS approach. Okay. Can you write down the pseudo code for it?
Okay. Can I write down in this GFG portal?
Yeah, okay. If you are comfortable with it, then why not?
Uh, in DFS, I will first uh, declare the answer and the level number one. Right now, by first take okay. Like I'm writing the function of DFS. Will return nothing void DFS not pointer and vector in which I am storing my answer. Right now,
Okay, you don't need to write down the full code. You can just write down the pseudo code. It will just save us some time.
if level number is odd, then we will go left children. Yes, left children first. And if level number is even, like if we are standing at level number 2, then we will have to go right children first. We will go right, right. I think
Okay, so means inside the BFS thing, you will be doing a DFS as well, right?
no. I am doing only DF.
Okay, you are using only DFS. All right.
Yes, in this I will do operations and I will insert the answer, the
Okay,
nodes
okay.
value.
All right. Yeah, so okay, the approach seems fine. We can use this as well. All right. So well done. So let us move to our next question, and that is, I'll write it down. Okay, before moving ahead, I was going through your resume, right? And I just saw your Code Forces profile, Lead Code profile. You are specialist at Code Forces, right? And a guardian at Lead Code. So why did you mention that in your introduction?
Like I'm thinking of including it, but like, it is a expert, not urgent, but I'm night at least.
Okay, so you were not audible. I'm not sure if the
Hello,
issue is from my end or if it's from your end.
your
So audience can help us with that. Were you able to hear what he said? Can anyone in the
hello,
chat section please confirm?
hello. I'm
Okay,
saying
now
that
I guess your connection is stable. Yeah. So
I'm
why didn't you
specialist.
mention it in the introduction?
Like I thought of including it, but I like let it go. And I'm expert at code forces and not guardian, but I'm night at lead code.
All right, that is yet a very big achievement, right? See, whenever you are introducing yourself in the interviews, what happens? Like we try to, you know, express our qualities. We try to show off ourselves, right? Like all the good things about us. So, you must be mentioning those things in the introduction as well. That leaves a good impression, right? So just that's one point. Keep that in mind. I mean, that is a big achievement, and you didn't add it. So just keep in mind that you should be adding it, right?
Yes, yes, I will. Yes.
Okay. So, okay, let us move to our next question. That is, you are given a positive number x, print the largest jumping number smaller than x, and for it smaller than or equal to. And then what is the jumping number? Jn, difference of adjacent digits is less than or equal to 1, right? These differ only by 1 is equal to 1, okay? So, for example, if it is x is 10, then output should be 10 as well. And if x is 50, then output should be 45, okay? So, is the question statement clear to you?
Yes. Like if the value of x is uh, value of x is always greater than 10 or smaller than 10 also.
Value of x can be anything starting from 1 to say 10 raised to the power 9, all right? And every single digit is considered a valid jumping number.
Okay.
Yeah.
So here the value of x is 9, then answer will be 9, right?
Yeah.
So if the value of x is 17, then we have to give the answer.
Will be 12.
Yes, yes, 12. Yes.
Okay. Because the
Okay,
difference must be 1.
must be 1. Yes.
Yeah.
Okay. Then, uh, so first I like I'm observing that we check in x that if it has the different digits and difference is already 1. If there is 1, then it will be fine to return the x only, or less than 10. Like if we have three digit number like 1, 2, 1, then this number is also a jumping number, right?
Yes.
1, 2, 3 is also valid number. Then, can you tell me the range of x like 1 to
10 raised to the power 9,
10 raised to the power?
all the integers.
All the, okay. So if we have the largest number, like we have to return the closest number which is jumping number to the x, right?
Yeah, I mean, if it is largest, then it will be closest to x.
Yes, that's why we
Yes.
can start from our index number.
Number itself.
Yes, yes, number itself, and we can go till the uh, till when the up we find the jumping number.
Okay.
Like we
And
are
how you
going.
will be checking the
Uh,
current number is jumping or not?
I will check it like a week. I create the separate function for it, uh, and check that I convert it to the string and then check it if it is jumping number or not. I consider two elements at a time and check the difference.
What will be the time complexity of this code?
Like x can be vary from 1 to 10 raised to 9. Then uh, order of x and the 10 raised to 9, then that is the very small number, but we have to consider it. That's why 9 into order of x. In worst,
Sorry, I didn't get
hello,
like
uh,
9 to, yeah.
9 is for digit. Like if we have the number 10 raised to 9, right? then we have to traverse nine digits in one go for the separate
Yes.
function which I used
Yes.
for checking. And we have to check for 10 raised to 9 numbers. Are you getting my point?
So yeah.
In
So
brute
I
force.
think it will be a quadratic time complexity.
No, no, no. 9 into order of x only. Because we are going from x to smallest number.
Okay. So the maximum length is going to be 9. All right. Okay.
Yes, that's why I taken the 9.
So it will be 9 into order of n, like, yeah, whatever is the integer value.
Yes, yes. Order of better.
So do you think in the worst case, I mean, let us say if the integer value is 10 raised to the power 9, say something like that. So do you think in that case your code will be optimal?
No, no, this is not optimal. This is the brute force one. Like
Okay,
you can
this is
use
the
this.
brute force. Okay, so can you write down the pseudocode for it, or do you want to proceed directly to the portal?
No, 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 no. I can write. Like I will create one function. Text number. For this function will return the number is jumping or not.
Okay.
Boolean. In this, I will create number in string, and we can also use the array and while loop, but it will take order of one and 9 at it is constant function. Then I
Okay.
will go from x minus minus, and for every time I will check the function is true or not. If it is true, then I will return that number. If this uh, function is true for any number, then I will return current number. Else, it will do minus minus and go. I have to like here is the condition. One edge case is there because if uh, uh, n is less than 10, then it will always true. Right? So this is one digit.
Less than or equal to 10, right?
Yes. This is the brute force one,
I
and
guess
let
you.
yes, yes, I'm complete it in the optimal one. I complete this function in optimal. Hello, hello.
Yes, yes, proceed.
Now, by this, we can observe that we have to find the closest number of x. Then we go from index number, like index digit, and we will minus it till the number we get to difference will be not one. I think uh, let's take example. So for this number, not equal anymore.
What are you trying to do?
1 minute. Thinking proceed.
are you speaking something or
No, no. If this will be
because
the number 4596, then this have to be answered, right? So this is the closest one, which is jumping number. Hello.
okay.
So
Like, is there any intention behind taking so large numbers? Or maybe we can do with taking small numbers as well.
okay, I got the intuition. Like for every position, we have nine numbers. So if we are standing at the uh, like we are indexing it properly, 0, 1, 2, 4. If we are standing at index 5, right, then we will try
Okay,
to then we will try to do the digit uh, at difference one, right? If the current digit is 9, then the one possible digit is only 8. So and we have to like we need a smaller number. That's why we cannot get 8. That's why we have to reducing the number 9 at 8. So in first iteration, we will get
what are you trying to do?
like I'm traversing from right. If I got this number,
You are
then
you
I
are
will
traversing your current integer. Like you have taken an integer and then you keep on decrementing it till you find a jumping number, right? And
no, no.
then
That's
right now
one
you
is
are checking that.
yes. Right now I am checking the only index digit, the zero, the fifth index digit. The rightmost digit is 6, right?
Okay,
Then I will check for 9. The difference is 3.
okay.
So I have to like 6 is lesser than 9. So I cannot increment it because we need smaller number than x.
All right. So are you like telling me the optimized approach?
Yes, yes, I'm telling the optimized approach.
Okay, so before doing that, I think you left that function incomplete, like where you were checking that if the current number is jumping or not.
Like
This bool
I will
function, right? You need to complete it
like
as well.
uh, I can just check the complex function.
Okay. So this is our brute force, and now you can start the optimized approach.
Yes. So for optimized approach, I will start traversing from right,
Okay.
from this index, last index. I consider I have transferred the number in string.
Okay.
Okay. Then currently I am standing at index 5 and I have 6, right? And at at fourth index I have 9. So 9 is greater than 6. Then I have to I need a smaller number. Then I cannot get 8, right? Are you getting my point?
Yes, I'm getting.
That's why I have to decrement 9 also.
Okay.
So I get 8 and the closest one is 9, right?
How did the 6 change to 9?
That is changed because the I got the 8 and in 8 I can get 9 and 7 for difference 1, right?
Hmm.
But I need a largest number, right? If I have decremented 9, so it will never get never exceed x, our given number. That's why
Okay.
I have converted into the 9. The 9 is optimal because if we take 8, 7, then 7 is the smaller number, but we need a larger number. That's why I have taken 10. Now the difference between 5 and 8 is also the 3. That is not the need. We need a difference 1. That's why we uh, like 5 and 8. That's why we decrement 8 to the 6 because hello, hello,
Yes,
hello,
yes,
okay,
I'm listening.
okay. uh, so the 5, 6, because we have to decrement it, we cannot increase it because we are considering optimal one.
Okay.
We can consider 4 and 6 also, but we need larger number. That's why I will converted into the 6, and the optimal one is 7. Are you getting my point? Hello,
Yes,
hello.
I'm in your point.
Okay. Now we
Am
are
I
at
audible?
index. No, you are breaking your voice. Voice is breaking.
Is
Okay.
now it is stable?
Yes, yes, it is stable. Now we are standing at index 3 at 5, right? So we need the 5 is and 4 difference is 1. Then we proceed further. Now we are standing at 4, right? We need the closest one to the 0. So we get the digit 1, right? Hello.
Yes, Divyesh, proceed. I am listening.
And the closest one to the 1 is 2, then 3, then 4. And now the this number is jumping number because the all the differences are 1. Now here the one case we need to consider is like the I think the all the cases are covered. Okay, I okay, we can go like
So just starting
the time.
and
Yes, I am starting
7.
from end.
Okay. So what will be the time complexity?
Time complexity is like constant, like big of 9. Like we have to traverse the now at max 9 digits because the max number is 10 raised to 9. And for this, like we have to traverse 9 times at max 9 times because we have to consider the all the nine. So 9 into 9
Okay, so
at max,
yeah,
right?
so I mean, you have converted your integer to a string and then you are doing the operations, right?
Yes, I'm doing the operation on that.
Okay, can you do this without converting it into string? I mean, the approach that you are using, that is more of a CP approach, right? I mean, nowhere it is wrong. It is perfectly correct. But can you try doing without converting it to a string? Because
Okay, and
sometimes it's like whatever the data is given to you, sometimes it is required that you are not changing the type of the data. You should use the data as it is given to you, right?
okay.
I mean, without any modifications. So if you can do it in any other way.
Mm, yes, we can proceed greedily also. Like if we are standing at position 1, right?
No, we are not converting it into string, right? So
Yes.
I think then there will be how you will
Okay.
position it.
Okay. Let's uh, try to find pattern because if the number is jumping number, okay, this is the jumping number. Like 4, 4.
Take your time, and if you need any hints, then do let me know. I'll help you with the hint. All right, you want me to help you with a hint?
Okay. Yes. Can you give me hint and data center or what?
See, what we can do is, let us suppose we are starting from the first jumping number that we have, right? Which is 1,
Yes. Yes.
correct?
Yes.
Yeah. So tell me, if 1 is the current number that you have, then what will be the next valid jumping number?
2 or 0. Oh, okay.
So that,
One is okay. Two. Next valid jumping number is
yeah, next. Okay, it will be 2. Now, suppose you have 1, 2 with you. Okay. What will be the
okay.
next valid jumping number?
Uh, Next valid jumping number
Like
is
you have
3.
12. You have 12. Okay.
Yes. You can get yes.
Yeah. So after 12, what are you going to get? Just say when it was 1, we had 12. Okay. Now we have 12. What is the next number that you're going to get?
Uh, like, 21. 21.
I mean, not like that actually. I mean, you know, after, by adding a digit, which extra digit can you add to 12 so that it will
Oh,
be
okay.
still a valid jump?
3. We can add 3 also. 3.
And
And 4. Okay.
not like that. I mean, see, if it is 1, 2, 3, sorry, it was 12, right? So 1, 2, 3 is a valid jumping number after adding an additional digit, and other can be 1, 2, 1, right?
Yes. Other can be 1 to 1.
Okay, now let us
Yes.
consider 1, 2, 3. For 1, 2, 3, the next valid numbers can be 1, 2, 3, 4 and 1, 2, 3, 2.
Yes. 1, 2, 3, 4 and 1, 2, 3, 2. Okay.
For 1, 2, 1, 1.
Okay. I get it.
Okay,
Okay. We,
okay,
we
so
start.
yeah, what
We
did you
start
understood?
from. We start from one, and we find the all valid numbers, all jumping numbers till 10 raised to 9, and then
Not till
we
10
have
raised
to
to
just
9,
binary search.
not till 10 raised to the power 9. Maybe we just need to find till the last number. I mean, if x is given to us, we need to find till x only, right? We don't need a
Yes,
number
we
greater
can
than
find.
x.
Yes, we can find till x. Yes, we can find.
Okay.
If I have the digit one, then 1, 2, 3. The 3 to 1 is also valid, right? 1 is also valid.
But yeah, it is valid, but we are not generating it from 12, right? So what I'm telling is that from every number, you can generate many numbers which are jumping numbers, right? So you
Yes.
need to consider all the jumping numbers that you can generate, and you need to consider it till that point till which it is less than x.
Okay. And I have to return the maximum one. Okay.
Yeah, and also you will need to use a data structure here, right? Like we are doing a certain kind of approach here. If you are able to visualize it,
Yes,
like first,
we can use Q. We can use Q.
exactly. So like this is a sort of a BFS approach, right? Like
Yes.
considering all the numbers and then generating numbers from the present number, right?
Yes. We every number from every number we try to generate the all the numbers.
Jumping numbers. Okay, so you can
Okay.
push it back inside the queue, and then you
And
can I like, yeah, like let us say in the first level of the queue, let us say if we are keeping, let us, okay, say in the first level of a queue we are keeping only first digit numbers, only one digit numbers. Okay,
yes, one, two,
so
three,
what you
four,
can,
five.
yeah, what you can do is in the next level, for one you can add 1 0 and 1 2, right?
Yes, we can add 1, 0 and 1, 2. Yes.
For
For
2 you can write 2 1
and 2, 3.
2,
Yes.
right? For 3 you can write 3 2 and 3 4, right? So I mean, so on, you can just keep on pushing back, and so our new queue will look like 10 12 21 23
And
32
32.
34. Are you getting my point?
Yes, I'm getting the
Yeah.
yes.
So now this was, let us say this is the first level. Okay, so the first level look like this,
Yes,
and now
first.
this is the second level of the second level will now look like this, right? Now how will the third
Yes.
level will look? For the third level, for 10 you will push the data, that is 101, and 101 will is the number, right? For
Yes.
12 you can push back 1 and 1 2 3, right? And so on, then we can have a third level,
Yes.
right? And for every
Yes.
integer
We
you
can.
can check that, yeah, whether it is the maximum integer that we are getting or not. Okay,
Okay. I get it.
so did you get the approach?
Yes, I get the whole of it. We can use Q.
All right. So, okay, if you got the approach, so you already did BFS in the previous questions, so I guess you'll be able to code it. And as we are running short of time right now, so okay, I'm just pausing it here. So, all right, that was all about the next question, and let us come to the feedback part. Uh, okay, so on the basis of this session, first of all, let me ask you, how much would you rate yourself?
I think 7.5, 7 or 7. There's a station. Hello.
7.5. Okay, that's pretty correct marking, I would say. So, with respect to first question was the level order traversal in spiral form. So you did it correct at the first go. There were no any blocks there, right? You completed it, and you explained other approaches as well. But there was like an additional function that you were using. So I asked you to tell me an approach that we can do without using that additional function. So you explained that DFS approach, and I'm pretty sure you'll be able to code that as well. So yeah, on that question, you were very much clear. The logic was clear to you. All right, all the approaches were clear to you. So 10 on 10 for that question. Okay. Now coming to this next question, you started well. Okay. The brute force approach was correct, no doubt. Brute force was correct. So the first thing that I would say you is that don't try to modify the data type that is given to you. All right, I mean, yeah, that is not actually preferable. In from CP point of view, that is completely correct. Okay, but from this interview point of view, you should try to not do that. All right, so that is there. And when I explained you the approach, that how we can use this BFS thing, so you were able to grasp it. So that is a good thing. You were able to understand my thoughts. All right, so that's a positive side. And as you used hint, so I will be not giving you 10 for this. So okay, maybe yeah, just 8 or 7.5 for this. And also one thing is that, see, two things actually. The first thing is that in your introduction you should have added your achievements on the lead code forces and geeks for geeks. All right, I mean, that are really achievements. When I went through your resume, it was very impressive, and that's why I kind of selected a little bit harder questions, right? Because your
Yeah,
profile was very impressive, so
yes,
the level of questions needed to be matched that thing.
yes,
So you need to add those things in the interview, right? That's a great thing that you have done. I mean, that is not something that you need to hide. Okay.
oh,
So in interview, that is what we do. We try to showcase our skills. All right. So keep that in mind. And secondly, I would say that maybe you can work a little bit on your communication skills,
okay,
because there were longer silences. All right, so I think that that point can be improved, and there is always a scope of improvement. We all are learning, right? So
yeah,
yeah, you can always exactly. So just try to little bit improve that. All right, your communication skills, and try to speak more, like communicate more, and try to think out loud. Okay.
okay,
So because if interviewer is able to understand what you are thinking, what you are doing, then that will be easy for the interviewer to analyze your skills, analyze your logical thinking. Okay.
okay,
Yeah.
okay.
So these are points. Yeah.
I'll keep
So
in
these are,
mind.
yeah, on, and also like on the logic part, on the problem solving part, you are really great. You did all that on a very decent level. Just for this communication skills maybe, and also maybe you got shy for explaining your achievements in the interview, like when I asked you to introduce yourself or whatever it was there. Just try to try to communicate. Okay.
Okay, okay.
Yeah.
I'll keep in mind
Okay.
with that.
So
Thank you.
yeah, so anything from your side?
It was great session. Thank you for giving me this opportunity, and I have learned a lot of things from this session. And thank
Great, great, Divyesh. We are equally happy to have you in the session. It was a decent session, and I hope our audiences will get a lot to learn from this session. All right, and we hope that this session will help you in your preparation journey as well. And we wish you all the best for your future.
thank you, thank you.
Okay, bye, Divyesh. Okay, so there it was, the interview session with Divyesh, and certain things that he needed to work upon was actually the communication skills, right? As we all saw that there were certain silences that was not looking pretty good. So that is something that we all can try to improve, to have a very good communication skills. And other than that, his problem solving skills were great, right? So that were some of the things about this session. I hope all of you liked it, and if there is any suggestions, any feedbacks, please feel free to add it in the chat section. And also, if any of you are interested to be a part of these sessions, then there is a Google form link that is added in the description of this video. Do fill out that form, right? And then we will be having you in our next sessions. There is no any such criteria that, you should be of this level or that thing. It's just that you should be good in problem solving, right? So make sure you are filling out that form. And that was all about today's session. Bye, everyone. Keep up the hard work.